this is the last problem set in the whole book. I hope you guys don't get too upset about that. We're going to review what the exponent rules are you've learned so far this chapter and tack on a few more. What have we learned so far? Let's see. If you have a base to a power, the power tells you how many times the base is multiplying itself. Anything to the first power is itself, right? Anything to the zero power is 1. When you have two expressions that are being multiplied with the same base, you can add the powers, right? Keep the base the same and add the powers. Negative exponents, when you have a negative exponent on the top, you can move it across the division sign, make it a positive exponent. Negative exponent on the denominator, move it up, cross the division sign, make it a positive exponent. So you could say cross the line, change the sign. And then the last rule we looked at last time, it is kind of like Rule 4 in a sense. Rule 6 says if you have a quotient with the same base, you subtract the exponent. It's kind of like saying if you have a product with the same base, you add the exponent. So see how they're kind of similar? Okay, well we're going to tack on a few more rules. These first two aren't too bad. We're going to have a total of 3 rules here, so we'll have a total of 9. These first 2 rules say, the first one says if you have a product of factors raised to a power, you have to raise each factor to the power. It does not apply when you have a sum. It only applies when you have a product to a power, raise each factor to the power. And if that seems reasonable, then this should too. This says if you have a quotient to a power, you have to raise both the numerator and the denominator to the same power. So let's look at some examples. Look at this first one. It says parentheses 2y to the 4th. Now you could write this as 2y times 2y times 2y times 2y, but what Rule 7 says, it makes it a little bit easier I think, it just says just raise 2 to the 4th power times y to the 4th power, so you get 16y to the 4th. Similarly, for this next one, you could write this as 4 over w times 4 over w times 4 over w and multiply it out, but Rule 8 might make it a little easier. It just says you could raise the numerator to the 3rd divided by the denominator to the 3rd, so your answer is 64 over w cubed. So that's what those 2 rules say. Okay, this last, let's do 2 more, then we'll talk about the last rule. Don't get it confused with this. When you have 2y to the 4th, there's nothing you can do to that. It's just y that's being raised to the 4th power, so nothing you can do. And similarly here, it's w that's being raised to the negative 3 power. I guess you could move the w up to the top and make it a positive power, but that's all you can do to that one. So make sure you understand what these rules don't say as well as what they say. Okay, here's the last rule. This rule says if you have a base to a power and that whole thing is being raised to a power, you multiply the exponents. You keep the base the same and you multiply the exponents. Power to a power, you multiply the exponents. Don't get it confused with Rule 4. It's very easy to do. Rule 4 says if you have 2 expressions that are being multiplied with the same base, you keep the base the same and add the exponents. So when you raise a power to a power, you multiply the exponents, and when you multiply 2 expressions with the same base, you add the exponents. Don't get Rule 9 mixed up with Rule 4. For example, look at these 2 problems. This says you have y to the 3rd raised to the 4th power, so that's when you would apply Rule 9, and you get y to the 12th. This says what's y to the 3rd times y to the 4th. That's where you would keep the base the same and add the exponents. You see, when you raise a power to a power, you multiply. When you multiply, you add. So your answer is y to the 7th there. By the way, these rules apply with negative exponents as well. You see, when you have x to the negative 3rd raised to the negative 4th, that becomes, you multiply the exponents and get x to the 12th. Here, when you have y to the negative 3rd times y to the negative 4th, you would keep the base the same, add the exponents, and you'd write your final answer as 1 over y to the 7th. Okay, now that we have all of our rules of exponents, let's look at some problems here. Probably be nice to keep these handy. Maybe write them on an index card or something. Just have them around until you learn them. Just to have them right there. And then also, there might be more than one way to do some of these problems. Don't think there's only one way to do them. But this first one looks like you have a quotient to a power. So doesn't it seem reasonable to apply Rule 8 to this? So you'd raise the numerator to the 4th power and the denominator to the 4th power, okay? Now what do you do next? Well, when you raise the entire numerator to the 4th power, you'd have to apply Rule 7 to the numerator, right? Because you have a product of things. So 2 gets raised to the fourth, becomes a 16, and you get a y to the fourth. However, on the denominator, you had an x squared that's being raised to the fourth. What do you do with those exponents? That's right, you multiply them using rule 9, so you get x to the 8th on the bottom. So let's keep on going here. On this one, let's see. On this one, you have quantity 4 over w to the negative third power. So what rule would you apply here? Let's see, it's a quotient. I'm thinking rule 8. If you apply the numerator to the third and the denominator, I should say negative third. If you raise 4 to the negative third and w to the negative third, you get this. How would you finish it up? You could get rid of the negative exponents by moving the w to the negative third up and the 4 to the negative third down. And then on the bottom, why don't you write this as 64 on the bottom? Okay. All right, let's look at k. At k, you have, looks like you have 3 things that are being raised to the, here we are, now you can see it. It looks like you have 3 things raised to the third power. So which rule would you apply here? How about the one that applies to products? You'd have to raise each of these factors. Negative 2 gets raised to the third, x to the 2 gets raised to the third, and y gets raised to the third. You see that? So what do you end up with? Well, negative 2 to the third is negative 8, but what's x to the 2 to the third? Isn't that x to the 6 using rule 9? And then you end up with y to the third. Okay, good. This is a sneaky one. What makes number L so different? It's because of this addition sign. Most of these rules of exponents aren't going to apply when you have things added. All you could really do here is use the definition of negative exponent rules, and you could move this down and call this 1 over 2 to the third, call this 1 over 2 to the 2, so you get 1/8 plus 1/4, and then you would treat this like a problem out of chapter 2, wouldn't you? You get the common denominator, and your final answer is 3/8. Okay, I think we've got time for a couple more. So when you get to these problems, like I was trying to get at, you have to decide on a strategy. And there might be more than one way to go. One strategy that I think it would be helpful for a lot of these problems, if you can simplify inside the parentheses, do it. So look at m. I think you could actually subtract those exponents on the x's. Couldn't you write it as x to the negative 2 minus 3? So I think that's good practice in general. If you can combine things inside the parentheses, do it. So that gives you x to the negative 5. It's still being raised to the negative 2 power. So what's your final answer? What is x to the negative 5 to the negative 2? Isn't it just x to the 10th? There you go. How about this one? On n. On n here, let's see, what would you do here on n? How about, again, number 8 applies when you have a quotient. You raise the numerator to the negative 2 power and the denominator to the negative 2 power. So what is x to the negative 2 to the negative 2? Isn't it just x to the 4th? And what's y to the third to the negative 2? It's y to the negative 6. You wouldn't leave your answer like that. You'd move the y to the 6 up to the top. So there's your final answer, x to the 4th times y to the 6. So these are kind of tricky. Let's see, why don't you try these last two on your own? I'll give you a couple minutes. Go ahead, hit the pause button. We'll go over these in just a minute. Okay, on the first one, my strategy would be to simplify inside the parentheses. So you could subtract the exponents. You get x to the negative 2 minus 2, becomes x to the negative 4th. This becomes y to the 1 minus 3, becomes y to the negative 2. Now when you raise each one to the negative 2 power, what's x to the negative 4th to the negative 2? You should get x to the 8th. What's y to the negative 2 to the negative 2? You should get y to the 4th. Now in this last one, I would move this 4 to the negative 1 down, call it 4 to the 1. Let's move this 2x to the negative 2 up. Notice it's the whole quantity that moves up. Let's move this x to the negative 3 down, call it x to the 3. I think that would be a good first step. Now you could apply rule 7 and call this 4x squared on top over 4x cubed. Don't the 4's cancel? And you can cancel the x's too, or you could say you could subtract the exponents, so your final answer, you just have 1 over x. Okay, we'll see you later. Bye-bye.